Morning and good afternoon. Assalamualaikum. So today we will proceed with differentiation. Okay, this one you had done with Dr. Ng, is it? Until this part, Dr. Ng. Is it correct? Forward, backward, and centered, right? Then to Dr. Ng. Right not? First derivative only, yeah? Right, first derivative. One apostrophe over here. First derivative. Okay. Have you gone through the example? This one? With Dr. Ng? No. Not sure? Yes. Done, right? Okay. Okay, so this chapter, differentiation, is related to this forward, backward, and centered difference. Okay. But previously, you are being introduced to only first derivative. Okay, first derivative means F apostrophe, one apostrophe only. Okay. Now, what's the difference between forward, backward, and centered differentiation? Do you remember? Okay, never mind. We go through again. Now, for numerical differentiation, okay, for numerical differentiation, okay, differentiation is the dy dx. Okay, differentiation is dy dx. Or in other term, f apostrophe x. Okay, that is differentiation. Now, first derivative. If f 2 apostrophe, so this is second derivative, right? Okay. Now, for this example, for this one, for this table, suppose you are given the following data and you want to find the derivative. You have x and y. Okay, so you need to find the derivative. Derivative is the dy dx. We know the dy dx is equivalent to the slope, isn't it? You have y2 minus y1 over x2 minus x1. This is the slope. Dy over dx, the slope, right? So that's why we have forward, backward, and centered. Okay, forward, backward, and centered. All are based on the Taylor series. Okay, now I will not introduce Taylor series again. Check one in your calculus, I think. Okay, where Taylor series, just a general one. First derivative, second derivative, third derivative, and so on. Okay, so that one is to find the next fx. Okay, where the h is the step size. Okay. Now for forward, okay, I straight away explain this one. For forward, you are given 1 point. Okay, this point. So forward derivative, you will need 1 point ahead. Xi plus 1. Forward, moving forward. Okay, so that is your estimation of the dy dx, which is the f prime x. Okay, that is the estimation, whereby the actual is this part. The actual, the slope that falls on the point. Okay, this is the actual. This is the estimation value. Okay, forward 1 point forward. If you have backward, okay, forward, this is the F just now. The difference in the F divided by the step size, the X. Okay, plus the error. Now, in differentiation, we also have OH, OH2, OH3. Okay, so the difference is the step size. OH2 is higher level, where the step size square of the step size. Okay, OH3, another higher level. Now, backward, it moves backward. This is the given X. Okay, so backward, you go back 1 point. Okay, so that is your estimation. The dy dx, which the actual is this part. Okay, that one backward. Notice the sign. Now, if centered, it is forward minus backward. Okay, where? This one. This is the given point. So you have forward and backward point. Okay, that is centered approximation. Now, the centered equation divide by 2h. Okay, why 2h? Because this is 1h, this is 1h. Okay?
Center is most favorite one among the forward and the
Yes. Centered, we consider as OH2, higher level. Okay? Now, this is how it represents for each of the derivative. Okay, the true exactly on the point. Okay, how to get your true derivative? True. Using calculator. Okay, ddx, calculator. Function ddx, function derivative. Okay, then forward, you are 1 point ahead. Okay, this one. Backward, point backward. Centered is in between these 2 points. So your actual point is in the center. Okay, now that is the derivative, the difference. Now, I will not lecture you on the how to derive the second derivative. Okay, we straight away use the equation. Now this is for forward. First derivative, second derivative. Okay, so here it mentioned the error level. First level, second level. Now notice the difference between first and second derivative. The equation is different. Okay, the equation is different. For first derivative, you only need 1 point ahead, xi plus 1. For second derivative, you need 2 point ahead. Okay, let's say you are given 1, 2, 4, 5, 6. Okay, so you here you have value lah. Okay, let's say you have value over there. So to find the second derivative, let's say this one, second derivative, xi. Let's say your x is 3. Xi is 3. Okay, so here fxi plus 2 plus 2 forward it should be this one. Okay, it should be f6 forward 2 points, then minus 2 multiplied by f1 point ahead, so this one would be f5. No, sorry, your xi is 3. Okay, 3 over here, so x1 x2. Okay, sorry, my bad. So here would be 5 and 4. Okay, then plus your f3 divide by your step size. Now, step size, what is the step size over here?
1.
1, correct. Step size is 1. How do you know 1?
Like 1, 1, 2, 3, 4, 5, 6.
xi plus 1 minus xi. Okay, the next point minus the previous point. Okay, this point minus this point, you will get h equals to 1. Or you get h equals to 1. Okay, that is your step size. Okay, this is in table form. But if you are given in graph point of view, okay, graph, so you will see, let's say here, you will have your point. Okay, then this is your step size, h, step size. Okay. First derivative and second derivative. Okay, differentiation is simple. You need to know what type of derivative, whether it is forward, backward, or centered. Then from there, the question required for first or second derivative. That's all. So here backward, first derivative you need 1 point backward. If second derivative, you need 2 points backward. Okay, just sub in the value. Okay, but you must know what is your fx first. If the question straight away give you the x and y, which is the fx, okay, you have the value, then easier. But if the question mention you equation, it gives you equation. For example, so each fx you need to find. Okay. Okay, this is centered first and second derivative. Okay. Notice the difference for the forward, backward, and centered. For forward and backward, if you notice, the arrow start with OH. Okay. Backward also OH. First level. But for centered, it's straight away second order. Okay, straight away using second order. Because the H is 2H. Okay. Now, in final exam, the first derivative and second derivative only will be given. The arrow level will not be mentioned. Okay, so you should know which arrow refers to which level. Okay. Now, we try this one example. given the following function, okay, this function, use finite divided difference with error of level 2 to estimate the derivative at x 2.2 using step size of 0.6. Okay, we do 0.6. Try for forward, backward, and centered. Okay, so identify. It requires error OH2. Now, does the question mention first or second derivative? There's no statement in the question, right? First or second derivative, right? Okay. If the question doesn't give any statement on that, you can use your own assumption. You can answer either one. Okay. Correct. Yes. Okay. Here it only gives error level, where the error level OH2 first and second both have error level 2. Okay. Now for this question, we just proceed with first derivative. Okay, we try first derivative first. First derivative. Okay. Forward. Okay, forward. O level 2. Make sure identify the equation. O level 2. Okay. Forward. Okay, go back to the equation. Level 2. This one. Forward level 2. Okay, so that is the equation involved. No, because the question asks for OH2. Correct, yes. It will mention whether first derivative or second derivative and also the error level. If not mentioned, you can assume your own error level. Usually the question will mention the error level. Okay, so using that equation for backward, we take first derivative, OH2. So this is for backward. Okay, then centered. Okay, centered, it starts with OH2. Okay, now sub into your equation. Now, let's try. Okay, in this example, it already showed you the fx. How to get this fx if it doesn't give you? Use the function given over here. Okay, the f-axis is from the function. Okay. Okay, we try first derivative OH2. Now remember your x 2.2, h is 0.6. Okay, we take h 0.6. Now first derivative for forward. Okay, check your equation. First derivative for forward. This one, huh? Okay, take note on the negative sign in front. Okay, don't leave out. Okay, using that first derivative equation, okay? So from here, which value is your fxi plus 2? Which value for fxi plus 2? We focus on H6. Step size 0.6. So this is your x. This is your x. Now, fi plus 2. What value? For fi, fxi plus 2. The fx.
Negative 47.
Yes, negative 47. This one. This is your xi plus 2. So this is your fx. Okay, sub this value into the equation. Then plus 4 multiply fx1. What is the value? 0.036 over here. This is your xi plus 1. This is your xi. Okay. Then minus 3 fxi. This one. Divide by 2h. Your h is 0.6. Okay, it looks simple, but you need to know your data, which is xi plus 1 plus 2, and the equation used. Okay, subs all the value, do you get this 81.5? 81.5. Okay. Now, same method, same step for backward. Identify your equation. Okay, backward. Identify your equation for O level 2, error level 2. No need to memorize the equation. It will be given. You just need to know which equation belongs to which. Okay. Now, this is your xi. So 1.6 will be xi minus 1. 1.0 will be xi minus 2. Okay. So sub all the value fxi minus 1 and minus 2. Okay, do you get the same? Negative 116.3898. Same, huh?
How do you know that this question requires you to do first derivative? Like it requires you to do first derivative and not second or third.
The question will mention. Later we will try the previous final exam question. Okay, clear? Easy, right? But previous semester, there were few students lost mark to here because use wrong equation. For example, this one, it asks OH2, but the student use OH level 1. So straight away, cannot get the marks. Wrong.
Is it going to be in order in the appendix?
Yes.
And point four,
Yes. Supposedly. Okay. Any question? Yeah. Now this is example from a textbook. Still using the same equation as previous example. Sorry, no. It use different example equation. Now for this question, it asks you to use forward, backward. Approximation of level 1. Okay, and a centered different approximation, level 2. Okay, now to estimate first derivative. Okay, so this question it clearly mentioned first derivative. So f prime x. Okay, the info that you should look into is the level of error, first derivative or second derivative, and your x. You need to know what is your x in order for you to set the point. Okay, so here the x is 0.5. Then the step size. You need to know what is your step size. The h. Okay, 0.5. Okay, so the derivative now. Here, take note, note that the derivative can be calculated directly as this. Now, this is directly derived from the equation. You differentiate directly from the equation. So when you sub your x into here, you will get the true value. Then another point. Okay, this equation, I highlight. This equation is directly differentiate from the main equation. This is the main equation. Okay, the one that you are required to find is the estimation. Forward, backward, and centered estimation from the given equation. Okay, now this equation is directly differentiate from the main equation. So when you sub x equals to 0.5 into here, you will get your true value because this is the actual derivation, actual first derivative. What we do for forward, backward, and centered, that is the estimation. Clear? If you sub back to the original equation, that is wrong because this one is fx. Okay, previous question where you get your fx, this one, this one, you mean this one? Okay, this fx from the equation over here. Now fx, not f prime x. Okay. Here, to get the true value, you can either directly derive from this equation or you can use your calculator. True value, 1 mark. Not to say the same, your answer will approach the true value. Will be approaching the true value. Good. Press calculator just to find the true value, right? So, in order to find the final answer for this example, you need all this data. True value only 1 mark. Derive. They derive from the actual equation, you mean? No need. Use calculator to find the true value, yes. Okay, so true value, just find your calculator, using your calculator. Usually 1 mark for the true value. Okay. Okay, then we proceed to find the x-axis and f-axis. Okay, x-axis, f-axis. Now remember, your x is 0.5. Okay, so forward O level 2, OH level 2. You need O level 2, forward. Wait, I don't memorize the equation either. Forward level 2. Here, this one. X plus 1 and plus 2. So you need, this is your xi plus 1. You need another one, xi plus 2. 1.5. Okay. Yes, repeat the same thing. Correct. Clear the concept on how to find your x and f-axis.
Are we going to we just put the length and the function?
For the true value, you can use your calculator directly. Okay, this one is, okay, for this function, you can derive easily. But how the function given like cos, sine, tan, something like that, exponent, okay? To find true value, I advise just to press your calculator. Okay? Now, from this value, x-axis and f-axis, sub into the equation. For OH level 2, so you should find the equation involve first derivative with OH level 2. In this question, it asks you to find forward and backward, then centered.
It is.
Correct, yes. Here, this is the overall solution. Okay, for backward, then centered. Okay, this is forward, backward, then centered. Okay, and the question also asks you to find True error. Ask you to find true error. Nak? Can we... Now, it doesn't mention to find true error. But here it shows you the true error. Okay, this one you can read the details in your textbook. That's why I always advise go through your textbook.
At one more X of
Mm-hmm.
X, X I must
For forward,
H
H 0.25. Uh-huh. If you require it, then you need to add one more. Okay, we go back to the question. Maybe we get confused somewhere. Now, the question asks you to find forward, backward, forward and backward for OH level 1. Now, this one use forward, backward. Centered different, level 2, centered. Forward and backward, level 1. So level 1, we just need xi plus 1 and xi minus 1 for forward and backward. Okay, just now, if it requires level 2 for forward and backward, you need extra points. Okay. Now, this is how they proceed for each of the axes and each step size. Okay. Now, this one, similar. This one from previous semester, not mentioned, but this semester I put label. Forward, backward, centered. But you need to know the level of error. I didn't mention the level of error. Should be in sequence. Should be in sequence. I arrange in sequence, so you should know which level of error. In your test later on, I will give the appendix similar to your final exam. So that you are familiar with yourself. Okay. Now, okay, we straight away go to final exam question. Sorry, this one is test. Okay, test question. Now, this question, it asks you to find forward peanut difference at accuracy level of H2. Okay, forward accuracy level of H2. This is your Fx. Now, what are the infos that you require? The step size, yes. Step size over here is 0.5. H equals to 0.5. Other info? This info is, there are few missing info in here. The X. Okay, the starting point. You need that starting point. So x equals to 3. Let's say x equals to 3. If this question were asked, it is lack of info where x and h is not given. So you can assume your own. I will see the step.
So we have to find if it's first derivative, second derivative. They say what derivative means.
Okay, yes. This one, now what derivative? It doesn't mention either, right? OH2, but it doesn't mention whether first or second. Yes, if it doesn't mention, you can choose. So this question, open-ended question. You can assume your own starting point, your own step size, and your own derivative. Okay, in this question. But to ease our exercise today, we just focus on first derivative. Okay, first derivative. Okay, first derivative, we do it for A, forward, finite different accuracy level of OH2. Forward, one step forward, 1 point forward. Level 2. Forward start with level 1, OH. Yeah, let's say you are not given the error over here. Make it bigger. How to identify? Now, how to identify if you are not given the error? First derivative, f prime. This one is second derivative, double prime. Okay, that you should know how the difference. Now, this one, it involves xi plus 1. So, forward. This is forward level 1. Simple. Okay, how about this? I plus 2, I plus 1. Right. Forward level 2. It requires more points, so higher accuracy, higher order. Okay, so the second derivative is for forward as well. How we know? I plus 2, I plus 1. So this one, it involves forward. Now this one, 2 points. First level as well. Second derivative, first level. Okay. Now this, I plus 3, I plus 2, I plus 1. Second level for second derivative. Okay, second derivative. So this one, second level. Yes. If it doesn't mention, can. But if it mention, you should follow the instruction. Yes. This question didn't mention. Huh? Go set lah. For test, I might ask for second derivative. My second derivative. Can ah? Okay. Now this first is for forward. Okay, next equation. First derivative. I use different color. First derivative. Now it involves xi minus 1. Backward. Minus. Okay, minus should be backward. First level, correct. Backward, first level. Okay, so when it involves minus, it always backward. It's just different level. This one O level 2. Second derivative, backward as well. Because I minus 1 and 2. This one level 2. Okay? Clear? How to identify the equation. Now, next equation. First derivative. It involves I plus 1, I minus 1. Forward, backward, or centered? Plus 1 and minus 1. Centered. Okay, if plus 1, minus 1, it is centered. Centered start with level 2. Higher accuracy. Okay, so this one plus minus. So centered higher level, OH4. No. Yes, it start with level 2. Wait, let me confirm on the level 2.4 or 2.3. 2.4, right? Okay, 2.4, right. Okay, now we proceed with the question. Forward, finite accuracy level of OH2. First derivative. Sorry. Now identify your equation. Forward O level 2. Forward O level 2. So this is the equation involved. Okay, what are the data? You need X for A. So you have your X, I. Forward OH level 2, you need XI plus 1 and plus 2. So I plus 1, I plus 2. Your X just now is 3. What is your X plus 1? 3.5. Right? How do you know 3.5? Step size. Okay, that's the function of the step size. 4. Yes.
But my school value is very big, 3 times on just 1 times the time to value.
One time.
1 time only value.
Because this first derivative, first, second, and third is the estimation. Estimation to find the actual value. Okay, find f-axis. Set the equation. So straight away you can get the value. Try to proceed. Do you get the same answer as your true value? True value, try to find your true value. You can write these down all the data first. Spell should be X model 3.
That's hard to do.
The equation over here is xe power 3. I make it bigger. Okay, again, the true value is not using this equation. The true value should be using the derivation of this equation. Or straight away, you use your calculator, sub for the ddx one. Okay, here, function of ddx. Okay, then sub, key in your equation, exponent, power 3. So power 3 okay, then comma, put your x value 3 equal. Okay, make sure the equation is correct. Okay, forward, can Now for centered, use the equation. Okay, identify the equation for centered. O level 4. Okay, centered, it requires O level 4. So identify your equation. First derivative, centered level 4, this one. Okay, so for B, you require xi plus 1 plus 2 minus 1 minus 2. Okay, so minus 1 I minus 2. Okay, or if you already know the step, first thing you can already set your data. Okay, your x, your f-axis. We already know centered level 4, we need I minus 2. So xi minus 1, your xi plus 1, I plus 2. So you just arrange your data first. Then straight away take the value. Okay?
Yeah.
That function. So for forward and center, you should get approaching to the true value, 29 something. Okay, can you move to next one? What? Percentage error? It doesn't mention to calculate. Do you calculate? What you get? Yes, possible. Yeah. Because the estimation value that you get is similar to your true value, right? Yeah. Yes. Possible. Okay. Shall we? Yeah. Now for the next question, It asks you to use the data now. This question already provide you the table of the data. To approximate f prime 1.2 by using second derivative of OH2. Second derivative. Now, it provides you the x and f axis. First thing, what is your x? What is your x? 1.2. How do you know 1.2?
There.
Here. Okay? This is your x. 1.2. What is your h?
0.4.
0.4. Okay, Wenkai, how do you know 0.4 is your h?
Table.
From the table, yes? How you get from the table?
1.2, get one above it, 1.6 minus 1.2.
Step size. Yes, step size of the axis. Huh? So this 0.4. Okay, so that is the h, step size. Now, second derivative. You look at f double prime. Forward, backward, and centered for O level 2, OH level 2. Now, this is for forward. This is for backward. Sorry, not this one. O level 2. Level 2 should be this one. Okay, so this is forward. Level 2. Backward. Level 2. Centered. Level 2. Second derivative. So look out for f double prime. Okay, f double prime. Now, forward, we do for, okay, so as overall, you need your point up to xi plus 3 and xi minus 3. Okay, in the table, where is your x? In the table, where is your x? Your x is 1.2, right? Okay, so this is your x. It's already given. Second derivative up to level 2. We need xi plus 3, xi minus 3. Okay, so moving forward, plus. Okay, identify your data. So this is your xi plus. Moving backward is your xi minus. Yeah, you look confused. Okay, so now the data is given. identify your data, yes. Okay, so please make sure you label your data correctly. Even though it is simple, but if you miss out the data, then your answer will be wrong. Okay, then subs all your data into the equation for forward, backward, and centered. This one, I'll give you the answer. You try on your own. Okay, for forward, it is negative. Okay, so these are the answers. You can try on your own. Last slide, just to discuss how to answer. You can proceed. Okay, this one can? Now, last slide from final exam May 2021. Now, you see the terms. Okay, you see the terms. Here, it doesn't mention terms of derivative. It mentioned compute the gradient. We know that gradient is dy dx. Correct. So, it refers to first derivative.
I want to see something.
Huh?
Then when there's like the word problem that refers to the second derivative, what words would they use?
Derivative, differentiation, gradient,
Gradients for first,
slope.
and then what's for the second one?
Second one, I think the terms is, I'm not sure. Gradient is referred to the first one. Okay. Okay, so here, identify your x, which is m over here given. Then this is your function. Step size of m. Okay, step size of m. This is your x, 0.5 pi. So it asks you to find out backward and centered. It doesn't mention which level, so you can assume any level. This question, the first level. This answer using the first. Okay, so that's it for differentiation. Easy, but make sure you use the correct equation. Okay. This will come out in your test.